Hey guys, Miss Blake here. We're going to start with section 2.1 in your book. First, we're going to talk about relations, a set of ordered pairs, x values being your domain, y values being your range. So if you look here, your domain is all those x's, 0, 10, 20, and 40. And our range is going to be all those y's, 9.1, 6.7, 12.3, and 21.2. A function, if you want to think about the definition, it's every element in the domain will be corresponding to exactly one element in the range. For every x, there is exactly one y. So if you look here, for 1, there is exactly 2. For 3, there is 4. For 5, right? 5 is in our domain. It corresponds with 6 and 8 in our range. This is not a function. Look at the next one. 1 goes with 2, 3 goes with 4, 6 goes with 5, 8 goes with 5. And I know you might be looking here and saying, whoa, 5 is repeated. It's okay. For every element in our domain, 6 is in our domain, it only goes with 5. 8 is in our domain, it only goes with 5. Yes, that is a function. Independent, dependent. Independent is our x values. Dependent is our y values. So to determine whether or not an equation defines y as a function of x, you want to make sure that for every x you plug in, you only get one y in return. So let's go ahead and get y alone. Subtract 2x from both sides. Got a negative 2x and a positive 6. Now, whatever you plug in for x, you're only going to get one number for y. Try it out. Plug in some numbers, see what happens. But you're only going to get one value. So yes, that is a function. It is a linear function. Here, if we subtract x squared from both sides, again, we want to get y alone. So we have a negative x squared and a positive 1. To undo a square, you square root both sides. So you got y equals, remember, plus or minus, and the square root of that side. So here, that plus or minus changes things. So if I plug in x value, I'm actually going to get positive and negative y values. So I'm going to get 2 elements in my range, which is a no-no. This is not a function. Function notation we're actually about to see. So in the next one, I went ahead and set these up. Basically, all I do is everywhere I see an x, I'm going to put an open set of parentheses. So function notation is the f of x. I always call it a fancy y. You might see g of x, h of x, all different ones. A says that they want us to plug in negative 5. Everywhere you see an x, we want to plug in a negative 5. So I'm plugging in a negative 5, plugging in a negative 5. And then you evaluate. We got 25, negative 2 times negative 5 gets me positive 10, plus 7, and add them all up, we get 42, and we're done. Next one, again, use those parentheses. Everywhere you had an x, put an open parenthesis, and we're going to plug in x plus 4 this time. Be careful on that first one. That is x plus 4 squared times itself. So you got to FOIL that puppy out. Or you could use the area model, whatever you used. X times x, x times 4, 4 times x, and 4 times 4. So be careful there. Combine your like terms, and we're going to go ahead and write it down here. So we got x squared plus 8x plus 16. Now we're going to distribute that negative 2, so negative 2 times x, and negative 2 times 4. And that plus 7 just stays on the end. Combine like terms and we're done. So we got x squared, x squared. 8x minus 2x gets me 6x. 16 minus 8 plus 7 is going to get me 15. And we're done. Last but not least, we're going to plug in negative x. So we're going to plug in negative x. Negative x squared is x squared. Negative times a negative is a positive, and plus 7 on the end, and we're done. Next one, they give us f of x and g of x and tell us to graph them starting with negative 2 and ending with 2. So we're going to go ahead and plug those numbers in. When you plug in 2, 2 times x, 2 times 2 is 4. When I plug in negative 2, 2 times negative 2 is negative 4. So we're going to have 2, 1, 2, 3, 4, and negative 2, 1, 2, 3, 4. And there's our first one. Next one, 2 times 2 is 4, minus 3 is 1. And negative 2 times negative 2 is negative 4, minus 3 more gets me negative 7. So we're at 2, 1, and negative 2, negative 7. And connect the dots. So it asks, how are they related? Notice this is f of x right here. All right, that's your f of x function. All we did was shift it down 3. Shift it down 3 units. And that's what that negative 3 is right there, right? We took our function 2x and we moved it down 3. What type of functions are they? Those are lines. Those are linear functions. Next slide. I did draw a couple more examples. So the vertical line test is to find out if something is a function looking at a graph. So remember, for every element in the domain, there has to be exactly one element in the range. So how does that look for a vertical line test? So if I draw a vertical line anywhere on this graph, I'm looking at B right now, anywhere on this graph, it should only hit the graph once, right? One element in the range. And that is a function, so B is a function. If you look at A, notice all that shading down here? That is part of your graph. This is an inequality. So if I draw a vertical line, it's very tempting to say, oh, it only hits once, but it's not. It's hitting numerous times. So that is not a function. Remember, all that shading is part of your graph. We look at C. I went ahead and drew a little parabola. So here, if I draw a straight line, I already hit it twice, not a function. Remember, you can only hit once. And D, again, if I draw a vertical line, I'm only hitting once. Yes, it's a function. So just some examples of that vertical line test. Looking here, we're talking about analyzing a graph about HIV infection and what it does to your T cell counts. So here, explain why this is a function. Vertical line test. All right, vertical line test, it passes. It's only going to hit once. F of 5. So go to 5. It looks like we're right at 400. What value of x is f of x 100? So 100, it looks like we're sitting at 9. And describe the trend. And I accidentally already have highlighting on this, but so this first part, right? So for the first 6 months, we see a rapid decline of our T cell count. So the first 6 months, there's a rapid decline. The next 6 months, you see a little increase. And then over the next several years, you see a continuous decline. So that's what they're talking about with general trend. I'm not going to write all that out, though. And last but not least, we're talking about domain and range from a graph. So domain, we're looking at our x coordinates. So x such that, and we're going to look here. We'll start with the lowest. So x is at -2. And yes, it equals -2. It goes through that point. But it's everything less than 1. So it's between -2 and 1. Or you could write this as between -2 and 1. And we use a bracket to show that, yes, it went through those points. Now we're moving on to our range. Our range is our y values. So we want to go as low as we can. It looks like we're at 0 all the way up to 3. So we're going to say y such that it's between 0 and 3. And yes, it can equal 0 and 3. So yes, you want those equal signs. Or again, you can 0 to 3. And again, we want brackets because yes, it can equal those points. Next one, see that open circle? That's going to affect, right? We cannot equal that point. So when we do our domain, it looks like we're -2 all the way to 1. Oops. All the way to 1. So we're going to say x such that x is between -2 and 1. Now it cannot equal -2, so we're not going to put an equal sign there, but it can equal 1, so we're going to put an equal sign there. Or -2 to 1. And again, -2, it cannot equal that, so you put a parenthesis. 1, it can equal 1, so we're going to put a bracket. Our range, we're talking about y's. Y such that, let's see where we're at. Lowest is -1 all the way up to 2. So we're -1 all the way up to 2. And can we equal -1? Yes. Can we equal 2? No. So here we're at -1 to 2. Yes, we can equal -1. Use that bracket. No, we cannot equal 2. We're going to use an open parenthesis. And last but not least, our domain. Our domain is our x values, x such that x, oops, where's our lowest x? It looks like we're -3 up to 0. So we're at -3, oops, -3 up to 0. Can I equal -3? Yes. Can I equal 0? No. So again, you can write that as -3 to 0. Yes and no. And last, range is our y's. Now y is a little weird because notice x's, I can plug in -3, -2.5, and I still get a coordinate because those lines are there. But here for my y's, I'm only plugging in a -3, a -2, and a -1. So we're going to say y equals -3, -2, and -1. Oops. Okay. So that's it. Hope it works. Tell me if you have any issues, and I'll post the homework that goes with this. Bye.